Let's start it off here. I'll give you a minute to mark whatever you need to mark before we talk, because take a look, be careful in your givens. I give you one figure is a parallelogram, but want to know another figure is a rectangle. So be careful, please. Be careful whatever you're going to mark here. Okay, let's talk. I'm sure with what'd you do? What do you know about perpendicular lines? They form? Okay, so I'm assuming, you got some of these boxes here, right? And one over here at F. That's what perpendicular lines do, form right angles. Okay. We have to prove DEFC. I did it in dashed here. Maybe, I don't know. I thought maybe it'd be easier to see. Showing that's a rectangle. All right, well, let's stop right here. Before you can show it's a rectangle in any of these proofs we're going to do, you need to tell me it's a parallelogram first. And we have a little bit of experience in that, a little bit. You may not be confident in that experience, but we got a little bit of experience in it. Show me DEFC as a parallelogram. So let's do that first as a class. That's what and I'll take over the rectangle part at the end. Show me DEFC as a parallelogram. And remember, let me go through the couple different ways we can do that. We can do this, right? Opposite sides congruent. What else could we do? We could show opposite sides parallel. What else could we do to make it a parallelogram? We could show one pair, what? Parallel and congruent. Yep. We could also do diagonals or bisect each other, but why is that totally out of the question? Impossible. Oh, geez, there are no diagonals. Thanks for the update. So I'm not even going to put that up there. So can we do any of these on DEFC? That's where you guys are going to take over now. Can you find me any parallel or congruent sides? And remember, hey, ABCD, that's a parallelogram. So maybe you can use some of their properties to help you out in this one right here. Maybe. So that's what I need your help in. It may be a little painful here, but show me that DEFC is a parallelogram, and then I'll take over. Hugh, what do you got for me? Throw it out there. Okay, so what you're saying, well, first you got to tell me AB is going to be parallel to, okay, everyone in agreement there. AB parallel to DC. Everyone agree with Hugh's statement? Okay, if you do agree, well, let me know why you agree then. Why is that true? 12, why is that true? AB parallel to DC. Parallelogram implies opposite sides parallel. Yep. Yep. And now, Hugh, explain to everyone what you wanted to do to AB. I'm taking side AB and everyone see that? So it should still be parallel to DC. So what should be parallel to DC now? I don't want to use all of AF. I just want to use the part I need in the parallelogram I'm trying to prove. Well, there's BF. EF, yep. And what do we have? Why is that? Oh, I know, Hugh, don't say anything. Why is that true? 18, why is that true now? What'd you do? Extensions of? What was the theorem? Extensions of parallel lines. You want to keep going? There you go. So all Hugh did was take that parallelogram and extend one side out. Boom, got it. So if I'm looking here now, I don't think this is going to help us out anymore. So either you guys need to get me the other two pair parallel or that same pair congruent. I don't know how you're going to do that, but we can talk. Can you get me the other pair parallel or that same pair congruent to each other? And the answer is you can. Look at the two. Hey, here's a hint. Look at those two right there. What do you know about DE and CF? We don't use it that often, but we've been using it quite a bit the last couple days, actually. What do we know about DE and CF, Nick? They're both perpendicular to AB, and if they're both perpendicular to the same line, what do we know about them? They are? Ooh, boy, we better know that theorem. They're not perpendicular to each other. Hey, guys, look at the darn thing, guys. DE and CF. Two lines perpendicular to the same line are parallel, yes. How saying it's perpendicular? DE parallel to CF, yep. Two lines perpendicular to the same line are parallel to each other. All right, so what do we have on our hands now? We just proved these two parallel. Hugh got us these two parallel. What is DEFC? It's a parallelogram. Did it. We did it. I just need to know from one of you guys why it's a parallelogram. Here we go, 17. Yep. Opposite sides parallel implies a parallelogram. So that's the first step. Show it's a parallelogram. Now I'll take over. How do I make it into a rectangle? What did you guys tell me at the beginning of class today? If you're a parallelogram, how do you make yourself into a rectangle? Show you have one right angle. Well, let's go back. Does this parallelogram have one right angle? Yes, but I told you it does. We've talked about it, but have I put it in my proof that it's got a right angle? Nope. So in my next step now, tell me where the right angle is now in the parallelogram. Where's the right angle? There's two places. Just name one. 13. Where's the right angle? CFB is a right angle. Why is it a right angle? Here we go. 12. Why is it a right angle? There we go. Now ready? Look what you wrote. You have a parallelogram with a right angle, makes it into a DEFC is a rectangle. What do you think the reason will be here? Not because it's got a right angle. I could show you many quadrilaterals that have a right angle, but they're not a rectangle. What made this into a rectangle? Go, Sean. Okay, ready? Parallelogram. Go. Keep talking. There you go. With one right angle. Keep talking. Implies rectangle. Yep. Great job, kids. Prove it's a parallelogram. Then tell me it's got a right angle or congruent diagonals. Whew. All right, ready for not a new type of proof, but a different way here to go about it. On the graph. Here we go. Go ahead, graph it and we'll talk. Make sure you're putting 0, 2 on the y-axis and 3, 0 on the x. Okay. Anytime we are asked to prove a figure on a graph, everyone ready? On a graph, we refer to these as coordinate proof, a coordinate proof. If it's on the graph and we're asked to prove a figure, it's called a coordinate proof because it's on the coordinate plane. We will not set up statements, reasons here, but we are going to be organized as anything, all right? You're still going to label your steps. Just won't be in 2 columns. You're still going to be labeling. What's it ask me to prove here? Prove that thing is a rectangle. What is great, and you guys may not think it's great, but what it's great about these coordinate proofs, you can do it any way you want. That last proof, we had to show it was a parallelogram and then get a right angle. You are free to do this any way you want, be creative as possible. Okay? As a class, we're going to make a decision, though, to do it one way, and then at the end, I'll talk about all the other ways. How do you make something into a parallelogram? Excuse me, a rectangle. Gave it away there. How do I make it into a rectangle? What are some of my options to show that this is a rectangle? So let's talk options. 16, what's an option? Great job. How about 3? Some options here for me. I could show this is a parallelogram and then show it's got a right angle. I could show it's a parallelogram and show it's got congruent diagonals. What do we want to do, kids? Well, either way, we still have to show it's a what? Parallelogram. Here we go. Oh, geez. We got options for a parallelogram, don't we? What do we want to do? Congruent sides, parallel sides, one pair of each, diagonals bisect. Class decision right now. What do we prefer? Opposite sides parallel, congruent, one pair parallel and congruent, diagonals bisect. What do we want to do? Do we have a preference? Okay, let's take a quick class vote. Opposite sides congruent. Anybody want to do that? Okay, I guess you guys won out. All right, so we'll prove opposite sides congruent. If we're going to do that, what am I going to need here? Distance formula. Okay, you wanted to do it that way? Let's do distance formula. So we got to find the distance of all 4 sides right now. Let's just review the distance formula. X2, you sure can, Cameron. Pythag away. Okay, so this is what you guys chose, by the way. Just throwing that out there. That's what you guys chose. So we need to find the distance of PQ. Let's start with PQ first. I'll give you guys a second to plug in the coordinates of P and Q. I'm hoping you get 6 and 4 in the parentheses, or -6, negative, some type of combination depending on what you went through. Everyone getting some type of 6 and 4 underneath. So you should be getting 36 plus 16. Check it out. Let's go. Should be getting square root of 52, I hope. Square root of 52. Okay, let's go. What side's next? Might as well do RS. Hopefully it comes out to be the square root of 52. We'll find out. Let's get going. RS. Keep it neat. Remember, keep it neat. What are you guys finding for RS? Another 16 plus 36? I hope. So that should square root of 52. Okay, let's keep going. QR. Go ahead and do QR and PS. I'll wait till you guys are finished. Hopefully those other two sides you're getting square root of 13. Hopefully you're getting 2 squared and 3 squared underneath. This is what's great about this. You do not have to, if you hate distance formula, you might be able to get away without doing distance formula at all. I'll talk about that at the end. We all good here? Everyone got the sides, square root of 13 and square root of 52. All right, next step, step 2. You will always tell me what you just learned from your formulas. You didn't learn it was a parallelogram. What did we just learn by getting square root of 52 and square root of 52? What's that tell us? You now know that PQ is congruent to RS, and what other two sides are equal? QR congruent to PS, and you, of course, got to tell me why. How do I know those sides are equal to each other? Let's get going here. How about 17? Why are those sides equal? Because distances are equal. So after you show me your formulas, tell me what you know now about the sides. Okay, keep going. Now, what do you know about the figure? What do you know about the figure if those pairs are equal? Here we go. 4. What do you know about the figure? Okay, PQRS is a parallelogram. Why, Rachel? There you go. Perfect. Okay. This is how every coordinate proof is going to go. You show me with the work of all your formulas. What'd you learn from your formula? What do you know about the figure? All right, how do I make it into a rectangle now? Another class decision. I could do one of two things. What makes this parallelogram into a rectangle? It has one right angle or it has congruent diagonals. What do we want to do as a class? Show a right angle or show congruent diagonals? It's up to you guys. Let's go right angle here. Okay, let's show it's got a right angle. Where do you want to show it's got a right angle? Pick the angle. Which angle do we want to show as a right angle? S? Okay, sure. If S is going to be a right angle, what should I know about these two lines? Okay, let's keep going. If they're going to be perpendicular, what formula am I going to need to prove that? Ooh. Which formula? Slopes. Two lines that are perpendicular. What do you know about their slopes? Negative reciprocals, yes. So everyone ready? Slope of PS. You can use change in Y over change in X, but I'll just show you a little quick way. You're probably going to graph most of these. Be asked to graph first. So ready? Just do rise over, run. How many up and how many over? Up 2 over 3. Just be careful. Look at PS, everybody. That's a negative slope because it's going downhill. Everyone see that? PS? So that's a negative 2/3. Now compare that to RS. Up and over how many? Up how many? Up 6 over 4. Take a look. Is this a positive or a negative slope? This is positive. Wait, they're not. They don't look anything like it. What? Reduce. 6 over 4. Woo, there we go. Now what am I looking at? Negative 2/3 and positive 3/2. Okay, so tell me in step 5 what you know now. Using these, no, I'm not ready to say it's a right angle yet. What did you just learn about RS and PS? They're perpendicular. RS perpendicular to PS because slopes are negative reciprocals. We're almost home. If I have perpendicular lines, what do I have? A right angle. Specifically where, though? You can't just name anything. Where's my right angle? 8. Angle S. Is a right angle. Why? Why, Nick? Yeah, just like we usually write. Angle S is a right angle because perpendicular lines form right angles. Are we done? Darn right we do. PQRS is a rectangle. Why? Because, stop, don't say anything. We'll hear from somebody. Because, here you go, 10. Well, I can show you a lot of quadrilaterals that have a right angle. It's a what with a right angle? What have we already said it was? Because it's a parallelogram with a right angle. That parallelogram part is huge. Okay, before we move on, let's just quickly. Hey, if you don't like distance formula, you could have showed opposite sides were parallel by doing slope formula. It's up to you how you want to do this. This is what's so nice about this. That whatever formula you're most comfortable with, you can use a lot of the time. Okay, if you like distance formula a lot, you could have proved the diagonals congruent instead of the right angle. Okay? Questions? All right, I'm going to skip over this proof here, and I'm going to go right to the other coordinate proof, so we're all good to go here for tonight. So go ahead and graph number 4 with the rhombus. Okay, people getting it graphed here. I'm going to let you and your group to decide by yourselves. I want everyone in the group to do it the same way, all right? But it doesn't have to be the same as the whole class. First off, before I show it's a rhombus, still got to show it's a what? Still got to show it's a parallelogram. So you guys still have to show me it's a parallelogram. But after you do that, how do you make it into a rhombus? We talked at the beginning of class. A parallelogram with what makes me into a rhombus? 2 consecutive sides congruent. So you could do that if you and your group want to. Or you could do what about the diagonals? Well, that's going to be, they do bisect the angles, but that's going to be hard to show on a graph. What other property do we know? Diagonals are perpendicular, so you could do that way as well. So I need you and your group make a quick decision right now. How are we going to show this as a rhombus Get after it step by step and let me see it when it's done, please. Amy, you want to join a group for me? Okay, you and your group do it the same way. How are you going to show it's a parallelogram, and then how you get into a rhombus from there? Distance, slopes, however you're going to do it.